I'm focusing on scikit-learn's Isotonic function. The *check_increasing equals true part means I'm telling the function to only find solutions where the output values increase or stay the same as the input values increase. This is a crucial constraint. I'm trying to figure out what happens when I use Isotonic with *check_increasing equals true , and my data doesn't perfectly follow the always increasing or staying the same rule. What will the model do? I'm checking if the function throws an error when the data violates the increasing rule. It doesn't. I'm testing if the model still works, but gives an answer, the fitted *y_, values. That might not be strictly increasing. That's exactly what happens. The output will be non-decreasing but not strictly increasing. Some output values might be the same. I'm seeing if the model will still try to find the best answer it can, even if the answer isn't perfect to meet the increasing constraint. That's correct. Forcing an increasing constraint can impact the model's overall accuracy. This refers to what the isotonic regression model produces, the fitted y values, which are the model's estimations of the target variable after it's been fit to the data. I'm asking you to choose the correct statements that describe what happens when you use scikit-learn's isotonic regression with *check_increasing equals true , and your data doesn't follow a strictly increasing pattern. The question tests your understanding of how the algorithm handles such situations. We're looking for a non-decreasing fit here, which means values are either increasing or staying the same, never decreasing. This statement is wrong. I'll tell you why. When using *check_increasing equals true , isotonic regression doesn't stop with an error message if the data isn't perfectly increasing. It tries to find a solution anyway. This is correct. The model will find a fit, but the fitted values, the *y_, values, might not always be strictly increasing. Some might be the same because the model has to balance between fitting the data and ensuring the values don't decrease. Nope, this is incorrect. Isotonic regression doesn't pick and choose. It considers all the data, trying to produce the best non-decreasing fit to everything you give it. This is also correct. The model will work hard to find the best fit it can, always making sure that the fitted values are never decreasing. But this might mean it can't get as close to the actual data points as it could if I removed that increasing constraint. This is a brief summary of option B. It emphasizes that the solution will be non-decreasing. I would expect some equal y values, because the model might need to flatten parts of the curve to maintain the non-decreasing property. This is the core of the problem. I'm using isotonic regression, a type of regression that specifically looks for a relationship between variables where the output values, y, never decrease as the input values, x, increase. The *check_increasing equals true part means I'm telling the model to strictly enforce this non-decreasing rule. This refers to the algorithm itself. Isotonic regression algorithms work by finding the best fit while maintaining monotonicity. That is, the output values either increase or stay the same, but never decrease. This is the condition, *check_increasing equals true , that we are imposing on the isotonic regression model. The question is whether the given data meets the constraint of the data being non-decreasing. If the data has points where the y values decrease as x values increase, the constraint is violated. This signifies that in this case, the input data satisfies the increasing constraint of isotonic regression. This introduces the multiple-choice quiz question. This is the data that we feed into the isotonic regression model. It consists of pairs of input values, x, and corresponding target values, y. These are the predicted y values produced by the isotonic regression model after it has been fit to the input data. This means there is a violation in the data which doesn't comply to the increasing constraint of isotonic regression. I'm considering the data you're using to train your isotonic regression model. This data consists of features, inputs, and a target variable, output, you're trying to predict. It's crucial that you understand how this data will affect the model's results. Let's dig in. This parameter within scikit-learn's isotonic regression tells the model to only find a solution where the predicted values are always increasing or staying the same. As the input values increase, think of it as a rule. The model must follow the non-decreasing rule. This is the type of model you are using. It's specifically designed to create a model where the output increases or stays flat as the input increases. We're checking how it reacts when the input data breaks this rule. These are the values the model predicts after being trained. They are an important part of understanding how well the model performs, especially when we add constraints like "check_increasing equals true". If the input data does not strictly increase, these values might not increase strictly. I'm applying the isotonic regression model with a specific constraint, the "check_increasing equals true" parameter. This forces the model to produce output values that never decrease as input increases. If this condition cannot be perfectly met because the data does not perfectly satisfy this, I'll explore how the model adapts. This section presents multiple choice questions that evaluate understanding of the isotonic regression model's behavior with the "check_increasing equals true" constraint. It tests if I understand how the model behaves when data doesn't perfectly follow an increasing trend. I'm using scikit-learn's Isotonic model. The parameter tells the model that I expect the relationship between my input features and target variables to always be increasing or staying the same, never decreasing. This is a crucial constraint. This is the data I'm feeding to my Isotonic model. It consists of pairs of x and y values where x represents input features and y represents target variables. After feeding the data, I'll check if my data actually follows the rule that enforces. Does my data strictly increase or at least stay the same from one data point to the next? If there are any instances in my data where the y value decreases as the x value increases, that means a violation. Yep, I've spotted decreases where the increasing constraint isn't met. Woohoo! My data beautifully follows the increasing constraint. No problems here. Even if there are decreasing parts, the model won't ignore them. It tries its best to find the best possible increasing fit, possibly averaging some points to enforce monotonicity. I'm aiming for a fit that is increasing or at least flat, even if that results in a slightly less perfect fit than if I allowed for decreasing sections. These are the y values that the Isotonic model predicts after fitting to my data. This is the final result, a fitted model and its predicted y values. I'm using scikit-learn's Isotonic model. The parameter tells the model that I expect the relationship between my input features and target variable to always increase or stay the same, never decrease. What happens if my data doesn't follow that rule? Maybe my target variable sometimes decreases as my input features increase. That's the problem this question tackles. I might think the model throws a valuerror, stops and complains, when the data doesn't increase smoothly. But I'm wrong. That's not how Isotonic works. The model still tries to fit the data. However, the fitted values, y_, might not always increase. It will do its best to stay non-decreasing, but there's no guarantee of a perfectly increasing line. The model will try to find the best fit, but it's limited by the increasing constraint. This might mean a less accurate fit compared to allowing the model to fit something that isn't strictly increasing. It's a trade-off between a perfect fit and enforcing an increasing trend. I might think the model ignores the parts of the data that decrease and only fits the parts that increase. However, Isotonic doesn't work that way. It tries to fit everything, respecting the constraint. It doesn't pick and choose. This is a multiple-choice quiz. I have to pick all the answers that correctly describe the behavior of Isotonic when I have this increasing constraint in my data. I'm using scikit-learn's Isotonic model. The "check_increasing equals true" parameter tells the model to only find solutions where the predicted values increase or stay the same as the input values increase. Think of it as a rule. The output can never go down as the input goes up. This is the data I feed into the model. It includes the input features, think of them as the x values, and the corresponding target values, the y values, that I'm trying to predict. I'm checking if the data satisfies the constraint that the target variable increases or stays constant as the features increase. This is what the check_increasing equals true parameter enforces. If the input data violates the condition of constantly increasing or at least not decreasing, then this is what happens. If the input data does not violate the condition of constantly increasing or at least not decreasing, then the model can produce a result according to the input. Even if my data doesn't perfectly follow the increasing rule, the model still tries its best to fit the data. However, the predicted values, y_, might not be strictly increasing. Some might be equal, but none will be smaller than the previous value for a bigger input value. Because the model is forced to maintain an increasing trend, it might not find the absolute best fit compared to if I allowed it to ignore the increasing rule, check_increasing equals false. The model's accuracy might be affected by this restriction. These are the values predicted by the model. If check_increasing equals true, these will form a non-decreasing sequence. I'm explaining why this statement is incorrect. Scikit-learn's isotonic regression, even with check_increasing equals true, doesn't throw an error if the data isn't perfectly increasing. It tries its best to fit the data while still following the non-decreasing rule. This is correct. The model aims for a non-decreasing fit, but it can't guarantee a strictly increasing one because it must accommodate all data points within the non-decreasing limitation. Some fitted values might be the same to stay non-decreasing. I'm explaining why this is wrong. Isotonic regression doesn't just skip over parts of the data. It tackles the entire dataset, but it'll make adjustments to satisfy the non-decreasing requirement. This is also right. Forcing the model to be non-decreasing when the data isn't naturally that way restricts the model, making the fit potentially less accurate than it would be without that requirement. This is the core question. It tests understanding of how isotonic regression handles data that doesn't perfectly follow an increasing trend when forced to do so.